Today we're going to talk about corrosion resistance of materials to acids, specifically sulfuric and hydrochloric acid. Why is this important? Well, an acid can be very corrosive to metal. You're going to get something like this, where the surface is just terribly eaten away. You thin it out and it looks terrible, and it can eat all the way through. And you don't want that to happen to your metal in the field. So alloy selection is critical. It's especially important to chemical companies and mining companies where they are using various acids at various temperatures. The tool we use to evaluate which alloy should be selected in a particular environment is called an isocorrosion curve. This curve can have only one alloy, or it can have multiple alloy. Each curve for each alloy represents the combination of temperatures and concentrations which exhibit a corrosion rate of 0.1 millimeter per year, or 4 milliinches per year. That's the number that's considered generally acceptable by industry. So the first acid system we're going to look at is sulfuric acid. The two alloys that are generally accepted by industry and widely used are alloy 20 and C276. If you look at their individual isocorrosion curves and compare them, they're almost identical. But if you look at the other isocorrosion curves, you will see another alloy that actually gives better performance in the dilute region and in the concentrated regions of sulfuric acid, and that's alloy Xeron 100. Xeron 100 actually shows corrosion resistance at an acceptable rate at the boiling temperature up to at least about 12–13%. And then in the extremely concentrated region, it starts outperforming all the other alloys from 92% to 100%. So it gives better performance in these regions at a much more economical price. So if you're operating in those regions, there's a better answer for you. The next acid we'll look at is hydrochloric acid. That's a much more aggressive acid to metals, but we use the same tool, the isocorrosion diagram. And in this case, once again, Xeron 100 does have some reasonable performance in the dilute range. It can be used up to about 1.7% at boiling and still give acceptable performance. And then as it starts sloping down, the downward slope is much shallower, which means it's more robust than many of the other alloys that can be used in the dilute range. So you really have to check the isocorrosion curve to see if that's right for your application. One final word on the isocorrosion curves of both sulfuric and hydrochloric acid. If you're in a range where you're above any of the isocorrosion lines that I've talked about in these graphs, that means you're going to have a higher corrosion rate than is acceptable, and that's going to mean you're going to have to start looking at more exotic, therefore more expensive alloys. If you need more information on this topic, please contact one of the RAMS group engineers or the group leader. You could do that using the email shown below, or you can dial our facility number, 800-521-0332, and ask to speak to a metallurgist. We're happy to help you in your selection of the right alloy for your application.